So now in 1.13, we're talking about absolute value equations and how to solve them. And it's important to realize what an absolute value actually is, right? We're typically taught that, oh, an absolute value makes anything inside of it positive, right? And what it's really talking about, though, is the distance a number is from zero. So if I were to draw a number line to try to describe this visually, here we have 0. And if I had something, let's say, like the absolute value of x is equal to 5, what this means is I'm looking for the distance that this number is from 0, right? And we know it has to be 5 units away from 0. So where on this graph can I find a number that's 5 units away from 0? Well, obviously 5 would be a possibility, right? Because between 0 and 5, that's 5 units. And another possibility would be over here at -5, because between -5 and 0, that's also 5 units. So I end up with two possible answers here. One possibility is that x could be -5, because -5 is 5 units from 0. The other possibility is that x is +5, for the same reason, right? 5 is also 5 units away from 0. So typically when we solve these equations, we want to look for two different possibilities, right? One is going to be a positive distance away. The other is still a positive distance away, but it's going to be a negative value. All right, we never really talk about negative distances. They're all positive distances. We just have to consider both the positive and negative locations on the number line. So step one when we're solving an absolute value equation is to isolate the absolute value. All right. Once you've isolated the absolute value, using division or addition or subtraction, multiplication, any of those operations to isolate it, you are then going to go ahead and consider the positive and negative distances. All right. Once you've done that, you're going to solve, that's not right. Solve both equations. And then I typically like to check my answer just to make sure I'm doing it correctly. All right, so those are the 3 steps to solving these, not too bad. And let's go ahead and take a look at an example here. So first thing I want to do is isolate the absolute value. So if I look at my equal sign right here, I see I have this 10 on the same side as the absolute value. So I'm going to have to move this 10 over to the right side. And if I move the 10 using subtraction, that's going to leave me with the absolute value of 2x plus 3 is equal to 5. From here, I want to consider both my positive and negative distances. So I'm looking for anything that's 5 units away from 0. So it could be the case that 2x plus 3 is located at +5, or it could be the case that 2x plus 3 is located at -5, right? Because we said that -5 and +5 are both 5 units from 0. So now I want to do step 3, which is to solve both equations. So on the left side, I would go ahead and subtract 3. I now have 2x is equal to 2. And when we divide both sides by 2 to isolate the letter x, we find out that x could be 1. All right, so I like to check my answer now. If we look at our original equation, if I take this 1, all right, and I plug it back in for x in my original equation, 2 times 1 is 2. 2 plus 3 is 5. We know that the absolute value of 5 is just 5, and 5 plus 10 is 15. So that is a possible answer. Then we can go over here to this other equation, and we're going to go ahead and solve this by subtracting 3 on both sides. We now end up with 2x is equal to -8. And when we divide both sides by 2, we find out that x is equal to -4. All right. So these should be my 2 answers. Let's go ahead and check the -4. All right, so we're going to plug that in for x. 2 times -4 is -8. -8 plus 3 is -5. We know that the absolute value of -5 is really +5, and 5 plus 10 is 15 again. So both of these are going to be my 2 answers. These are the values of x that would make the absolute value, the 5 units away from 0. All right, let's try one more example. All right, let's take 3 times the absolute value of 8 minus x, and let's set that equal to 12. All right, And what I'm going to go ahead and do is I'm going to go ahead and isolate this absolute value. So I'm going to go ahead and divide both sides by 3. All right, 3's will cancel on the left because 3 divided by 3 is just 1, leaving me with the absolute value of 8 minus x is equal to 4. So again, I'm looking for where is this number 4 units from 0. Well, 8 minus x could be located at positive 4, or 8 minus x could be located at negative 4. Both of these are 4 units away from 0. So we solve each of these separately. We're going to go ahead and subtract 8 on both sides for the first one. This is going to leave me with negative x is equal to negative 4. That's going to mean that x is equal to positive 4 when I just change the signs. Or the option over here, if I subtract 8 again, trying to isolate that letter x, we now end up with negative x equals negative 12. Again, just change the signs, and x will be positive 12. All right, we can go ahead and check our answer with the original. So if I go ahead and plug in the positive 4, 8 minus 4 is 4. Absolute value of 4 is still 4. And 4 times 3 is 12, so that works. Then let's check out the positive 12. 8 minus 12 is negative 4. Absolute value of negative 4 is positive 4. And again, 4 times 3 is positive 12. So we do get 2 possible solutions. All right? And then one last example, not to be tricky here, but I'm going to make it a little tricky. All right, example 3, let's take absolute value of 3x minus 11, and let's make that equal negative 10. All right, now for this problem is nice because it's actually already isolated over here on the left, right? I don't have to divide or multiply or add or subtract to isolate this absolute value. So now I'm going to go up and I'm looking at step 2, which says to consider both the positive and negative distances. Now we run into an issue, right? Because when I think about distance is always a positive value, right? We know that if we think back to that number line, 5 is a positive 5 units away from 0, and negative 5 is also a positive 5 units away, right? We don't talk about distances as being negative distances, all right? So the issue here is that I'm never going to be able to solve this, right? We know that this distance is going to be positive, so how is it possible that I can make a positive value equal to a negative number? That doesn't make any sense at all, right? So we know that whenever you have an absolute value equation that is equal to a negative, this is not going to be possible. So there is no solution. All right, you cannot ever have an absolute value equal to a negative number because distances are always positive. All right. So one thing to consider, you might see that in the CK12 or the homework. Good luck.